I've got a challenge for you. I've got a deck of cards. If I take them and shuffle them so they're largely randomised, there we go. What strategy would you use to put them back in the correct order? How would you turn that back into a sorted sequence of cards? Why are we looking at cards anyway? Well, it turns out that trying to sort data, or cards, is one of the most fundamental and important things computers are used for. Today, we're going to look at how we instruct computers to sort data. How many people are in your country? I live in England, and there's about 56 million of us jammed into this tiny island. I know that because Google told me. Google knows that because every 10 years, the Office of National Statistics does a countrywide survey, known as a census. To take part in a census, all I have to do is fill out a form and post it off. Or I can do it online. All that data gets collected and organised, obviously by a computer, but that wasn't always the case. Let's go all the way back to 1800s America, specifically 1880. If Hollywood is to be believed, 1880s America is a wild place full of cowboys, violence, and quite a lot of mud. It's quite crazy to think 100 years later we'd have time-travelling DeLoreans. But back then, they also had a census, and it was 100% manual. At the time, the US had somewhere around 65 million people living in it. They didn't know the exact number, that was the point of the census, and it took a lot of people to carry out. I found the instructions from 1880 on how they did this. It says, 150 supervisors of census have been or will be appointed, one or more for each state or territory. The Census Office has favoured the plan of small subdivisions. The average estimate of population is not in excess of 2,000. It is anticipated that the total number of enumeration districts for all the states and territories will be closely in the neighbourhood of 28,000. So, there's 150 supervisors in charge of around about 28,000 districts, each one with around 2,000 people in it. To do the census, what they need to do is designate suitable people and to employ them as enumerators, the people that do the census, one for each subdivision. They then have to transmit to those enumerators the printed forms and schedules issued by the Census Office, in quantities suited to the requirements of each subdivision. So it's all paper-based. Lots and lots of papers being sent around the place. And then to provide for the early and safe transmission back all the returns from the enumerators. So all this paper goes out, it then comes back in. They then have to examine and scrutinise all the returns to check that they're not wrong and that they've not forgotten to go somewhere. And then forward all of that to the superintendent of the census, the completed returns for that district. So as an enumerator, the person who walks around the place doing the census, what they need to do, and I've found a form that they fill in that will be on the screen at the moment, they have to visit personally each dwelling and each family and each individual living out of a family in any place, and then make entries, names, figures on the schedules, and they need to write clearly and neatly. So they're asking people their name and other details and then writing it on a piece of paper. The 1880 census took nearly 7 years to complete. 7. The next census was due 3 years later because they do them every 10 years. And they'd only just finished processing the previous one. So the concern was at this rate the census would never be finished before the next one would even start. If it takes you 7 years to finish processing a census that happens every 10 years and your population is getting bigger, at some point the next one's going to be starting before you finish the previous one. So clearly something had to be done about this. Well, in 1888, and maybe 2 years before the next one, so cutting it fine, the Census Office held a competition where contestants could invent new ways of processing data. So in other words, they were stuck and they were hoping someone else would think of a good problem for them. And as we're about to see, someone did. Hermann Hollerith was born February 29th, 1860 in Buffalo, New York. He found school difficult and ended up being privately tutored. By 1879 he graduated as a mining engineer, but by 1880 he was working for the Census Bureau, so he had direct experience of the problems that they were encountering. Around this time he also met a person called Dr. John Shaw Billings, who was also working there. He was a librarian amongst many other things, and he's reported to have said to Hollerith that there ought to be some mechanical way of doing this job, something on the principle of the jacquard loom, whereby holes in a card regulate the pattern to be woven. This gave Hollerith an idea, and in 1882, while now working at MIT where he taught mechanical engineering, he experimented with using punched paper tape to record data. He found the paper tape was too fragile and finally settled on using card instead. He created a patent for a machine in 1884, while now working at the patent office. And this new machine was called a tabulation machine. And it would be this device that ultimately won him the 1888 census competition. What it did was allowed people to record data on pieces of card with holes in, and then the machine could count and sort and tabulate all that data by itself, instead of requiring people to read and calculate and write down numbers and sort pieces of paper. In one particular challenge, it took his machine 5.5 hours to complete a task that took his competitors over 44 hours. So clearly he won. Things didn't end there for Hollerith either. His device and several others, with other people involved, merged in 1911 to create a company called the Computer Tabulating Recording Company, or CTR. They produced all sorts of useful machines. They were all mechanical, and for doing things like timekeeping, or weighing, or counting, or slicing meat. Because I guess it's important to know how well your meat is sliced. It predates sliced bread, so it must be good. Things continued going well for CTR. By 1933, they renamed themselves to International Business Machines, or IBM. They're a computer company. You might have heard of them. They were quite big in the 80s. What they did in history is well documented on the internet, and a story for another day. We're going off on a different tangent. But what has this got to do with sorting playing cards? I'm not going to start punching holes in my cards and building a machine to sort them for me. Let's have a look at another period in history. Coincidentally, this one also involves the US Census. You can't beat a regularly timed data-intensive task for getting an engineer's brain working, can you? Fast forward to 1945. The Wild West has been replaced with an even wilder world. Instead of Americans fighting amongst themselves, the whole world is having a go. It's the final stages of World War II, and the Americans are getting ready for their big finale. To do this, the US Army needs ballistic trajectories calculating. There's a lot of maths behind throwing explosives at people, and all that maths was done by computers. Now in this instance, a computer is a job performed by people. That's where the word actually comes from if you didn't know. A computer is a person who computes, in the same way a painter is a person who paints. In a bid to speed this process up, the US Army financed the creation of the world's first electronic computing machine, called ENIAC. This was the first Turing-complete computer, which meant it could be reprogrammed to do other tasks. It wasn't just fixed in what it was doing originally. One of the programmers working on it was called Betty Snyder. Originally hired by the Moore School of Engineering to work as a computer, she was chosen to be one of the 6 women to program the ENIAC. Now back then, programming wasn't typing on a keyboard. It was physically connecting parts of the machine with wires, a bit like an old-style telephone switchboard. After the war, she worked on another machine called the UNIVAC-1 to create the first sorting and merging generator, which Grace Hopper, who is another highly regarded computer scientist, used while inventing the concept of compiling code. So we've just seen that sorting data requires immense amounts of effort, and condensing that effort into a machine requires a lot more hard work. It's literally the whole reason we have any computers at all today. Everything, like you watching YouTube and me making these videos and editing them on a computer, it all came from this beginning. Just this desire to count and classify things and people. But just how do we instruct a computer to do this? I'll get my cards back out and we'll have a look at some techniques. So if you're still watching, thanks for sticking around. It takes quite a lot of effort to make these videos. And knowing there's people that actually watch more than the first 30 seconds is quite motivating to make me want to do more. So if you're having fun or watching this video and you're still with me, stick a like down the bottom just so I know that you're still there. You might know this game by a few names. I know it as Solitaire. It's an intensely frustrating game, as you can see when we're playing it at the moment. But if you win, you end up with a sorted deck of cards. It's one way to sort a deck of cards. They turned it into a game. I quite like the Windows 3 version. That's where I first learnt this game. I remember finding it in Windows 3 and being taught how to play it by my mother, which baffled me because she didn't know about computers but knew how to play a computer game, and I didn't realise it was an actual real game. There are other ways of sorting these cards though. But first, let's explore how people do it. How do you sort a deck of cards? It's a weird question, really. It's almost insultingly simple, because you just get the cards and put them in the right order. Like, if I take a handful because it's easier to work with them, well, that one can go at the bottom, and then that one can go there, and that one can go there. And all I'm doing is just finding the right place for each card. I'm not sorting by suit as well at the moment, but if I was, then there'd just be separate little piles of each one. Then I've merged them all together. But you can see I'm just finding where each card needs to be. This is so obvious that kids figure it out without needing to be taught how to sort a deck of cards, you know? You just play with them and figure it out. And there, they are now all in numerical order. Does it matter that that 3 comes before that 3, or that 3 is after that 3? It might do, it might not. But how would we write this as an algorithm? What even is an algorithm? We'd best do that bit first. Well, an algorithm is a sequence of steps that solves a specific problem. It has some input, it does some processing, generates an output. In our case, the input is a load of unsorted cards. The processing is to sort the cards, and the output is a sorted deck of cards. The best way to write an algorithm is to attack it with a strategy or two. Common ones are lumped together under the heading of computational thinking. So yes, there's an algorithm for writing algorithms. That's how computing people's brains work. So you begin by trying to understand the problem. We want to sort the cards. This though is a big problem, it's a bit too difficult, so we need to identify the important parts. We call that abstraction. So what's important? Well, it's important the cards are in sequence. It's important the cards are grouped by suit. That's it. We don't care about anything else. There's a card in here that's got an onion on it. Okay? And someone's written all over it. That's irrelevant to the sorting. It's relevant to me, but not to sorting these cards. All we care about is its values. That's an ace of spades. That data there is important. We then need to decompose the problem into smaller sub-problems and look for patterns. So the method I've done so far seems to involve the following steps. So I take a card and I compare it to all the other cards, and then I put it in the right place. Then I get the next card and I do the same thing. And I repeat this process until all the cards are in the right order. So I just take each card and I figure out where it needs to go. Now, computers are a bit funny when it comes to repetition. They need telling to repeat a set of instructions before being told what those instructions are. So let's shuffle our algorithm around a bit. So what we have is, while the cards aren't yet sorted, pick up a card, compare it to all the others, put it in the right place. And you just keep doing that until the card's just sorted. This is better, but the middle bit of comparing it to all the other cards and putting it in the right place is a bit vague. What we're writing here actually has a name. This is called a linear search. Here is the actual algorithm. It's a very repetitive algorithm, doesn't use any human intuition. So let's look at a different algorithm. This one's called a bubble sort. It's like the classic one that all computer science students are taught because it gives them sort of something a bit more difficult to think about. It works by comparing only pairs of cards. So you look at the first two, and if they're in the right order, you leave them alone. If they're not, you swap them over. You then look at the next two and do the same thing. And the next two, and the next two. When you get to the end, you go back to the beginning and you do it again. So they're in the right order. They're not. Neither are they. Those two are. And you go back to the beginning. So they're in the wrong order. You can see all I'm doing is looking at two cards each time. Now this is the annoying bit. You have to go back through it, and you only stop if you've not swapped anything. So it was obvious just by then that they were all in the right order, but the algorithm carries on for the next step, and it only stops when it hasn't swapped any cards. It was invented in 1956 by a mathematician called Edward Harry Friend. It isn't very smart and it contains a lot of repetition. In fact, it's worse than an insertion sort. You wouldn't bubble sort a deck of cards. An insertion sort is good enough because there's only 52 cards, it's not a big deal. And that's the whole thing with sorting. There's so many different ways. Each has a benefit and a drawback. Entire books have been written on them and how to choose the best. They don't say very good things about the bubble sort. Here's a quote that I found. Here's some more complex sorting algorithms. This one's called a merge sort. It works by using something called recursion, which is a topic for another video. This is also why sorting is taught in computer science. It introduces a load of other concepts in quite a natural way. You get lured in by people like me just saying, so how do you sort a deck of cards then? Let's have a go at writing some instructions for it. Next thing you're down a rabbit hole about number theory and wondering what you're doing. You see, it turns out that not every sorting algorithm is equal. Some are faster than others, some are slower, some use more memory, some use less memory. If you've got a small microcontroller trying to sort some data it's gathering, it might use a version of a sorting algorithm that doesn't store much data whilst it's sorting, compared to trying to sort something on your computer where you've got gigabytes of RAM. There's this whole thing called big O notation that I'm really not going to go into. Here's another sorting routine called a quick sort. It is quick. That's why it's got the name. It's probably the algorithm that's used most today, and it comes built into many programming languages by default. If you've ever used Python and its lists, and you've just told it to sort a list, it's probably used the quicksort algorithm. It also uses recursion. It's got a really vague explanation of how it works, and it sounds deceptively simple. But if you look at the code for the algorithm, it's really confusing. There's a recursive call that just gets in your brain and confuses you trying to step through it. For all their amazing capabilities and their ability to sort data, computers can do some pretty weird things occasionally that don't make any sense. Let's look at one example as a last little thing. If, like me, you tried to keep your files organised, try being the operative word there, you might have tried numbering folders. Or maybe your own legal collection of MP3s all start with the track number. Notice how the computer seems to have forgotten how to count. Last I knew, we didn't count 1, 10, 11, 2, 3, 4, 5, 6, 7, 8, 9. The 10 and 11 are in the wrong place. Why is this happening? Well, it's all to do with how the computer is sorting the data and what data it's actually sorting. To us as people, these should obviously go in numerical order. 10 comes after 9. To a computer, it is being sorted in numerical order, just not the order that we think. The computer doesn't see this as a digit 1, and this is a digit 10. It sees ASCII codes. This is the ASCII code for a number 1. These two ASCII codes are the digits 1 and 0. If we write out the ASCII code for the numbers 1 to 12, we might spot a pattern in them. And if we now organise them by their ASCII codes, it definitely makes a pattern. It's worth pointing out modern Windows seems to have fixed this oddity, and it now does order their folders and files numerically. It's not 100% consistent though. In the terminal it's still alphabetical. So there we are, a bit of a ramble around why the need to sort data directly led to the invention of the computer and why it still continues to be an important use of our devices today. In the next video, I'll be looking at how needing to accurately calculate maths accidentally led to the invention of the desktop calculator. So if this video was interesting and you just found it randomly whilst browsing YouTube, consider subscribing so you get notified when that new video comes out. The YouTube algorithm might otherwise decide your next video is on carpet cleaning or tiny houses or whatever else random it just pops up for you to look at. Either way though, thanks for watching all the way to the end. If you made it this far, leave a comment with the name of an important historical computer event or person that you might want me to look at in the future. I'm always open for ideas. Until next time, I'll see you later. And you move on until they're all sorted, like this. So that was a really shit example, because they're all sorted already.